Hello, Bearcats. Today we're going to analyze rational functions, identify horizontal asymptotes, vertical asymptotes, slant asymptotes, and holes in graphs, and we'll be able to sketch using all that information. Rational functions, as we know and have discussed yesterday, are polynomials divided by a polynomial, written as f of x equals the numerator polynomial and d for denominator polynomial. So I'm going to refer to n as the numerator, d as the denominator. Because we're dealing with a denominator, we have to watch for domain restrictions. We talked about this yesterday, and these restrictions are also our vertical asymptotes. So big report, like that's one of those emergency signs. So vertical asymptotes are the line of the domain restriction. So, in other words, if we have 2 over x minus 3, x cannot equal 3 is our restriction, and x does equal 3 is our vertical asymptote. Woohoo! Go Bearcats! Okay, now I just want to review the steps for graphing rational functions. The first thing we're going to do is simplify, if possible, and we're going to identify any holes. We do that when we have those cancellations, and we're going to do that on the next page with a little extension there. The holes do occur when where you have any kind of cancellations when the numerator and the denominator. The second thing we're going to do is we're going to plot the y-intercept, which means when x is 0. You could just plug that in. The third step is we're going to find the x-intercepts by finding the zeros of numerator. The fourth step is find the zeros of denominator and sketch the vertical asymptotes. Number 5, we're going to find and sketch our horizontal asymptotes. If none, then we'll use, if the degree is larger by 1, we'll use long division to find our slant asymptotes. We're going to plot additional points. And finally, sketch a smooth curve. All right, go Bearcats. Okay. In this last section, we're going to extend a little, and we're going to look what happens when we find a hole or slant asymptote. In this particular case, we know we have we're going to factor both the numerator and denominator. So when we do, we're going to get x plus 2 times x minus 3. In the denominator, we're going to get x plus 5 times x plus 2. All right, we know that our vertical asymptotes would be at, oh, wait, though, we have a cancellation. We want to simplify first. So our domain restrictions would be x cannot equal -2 or -5. We're going to go ahead and make our cancellation. So that was a domain restriction, but our vertical asymptote is going to be at -5, x equals -5, and we have a hole where x is at negative 2. We'll find the y part of that in a minute. So be really, really careful. This comes from this because of cancellation. This comes for this. All right, so we've simplified our equation into x minus 3 over x plus 5. And to graph that, we're going to graph our vertical asymptote at negative 5. We're going to look at horizontal asymptotes. Well, the degrees are the same, so our horizontal asymptote would equal y equals 1. We have a hole at negative 2. We have a hole at negative 2. So what that means is at negative 2, we have a hole. So we're going to plug negative 2 into this equation. So we have negative 2 minus 3 and negative 2 plus 5. That will be negative 5 over 3. So negative 5/3. So negative 5/3, which is not quite at 2. So we're going to say 1, 2. And when we get to our graph at negative 2, 5/3, we're going to put a hole in our graph. Now, sketching our points. Our y-intercept is when x is 0, so that's going to be at negative 3/5. So our y-intercept is at negative 3/5. We'll put that about right there. Our zeros are what makes the numerator 0. In this case, that would be positive 3. So 1, 2, 3. So it looks like to me we're going to have part of our graph down here, and we're going to have part of our graph up here. And we have a hole at negative 2, negative 5/3. So at negative 2, negative 5/3, we'll just go straight down, and we're going to say that's about where our hole is. All right, so we're going to go negative 5/3 over here. Let's take a look now at one more. Let's take a look at this example. So I'm going to go ahead and factor x plus 2, x minus 2, all over x plus 3. No cancellation, so no hole. Now let's go back and take a look. Vertical asymptote, of course, will be where x is equal to negative 3. Our domain restriction would be x cannot equal negative 3. For our degrees, our horizontal, so let's go ahead and just sketch that in. So our vertical asymptote's at negative 3. All right, our our horizontal asymptote, let's go back. Our degree at the numerator is larger, so y equals 0. So this would be our horizontal asymptote. The next thing we want to look for, bigger at the top, that's not true. Bigger at the top means the horizontal asymptote is none. Sorry about that. Bigger at the top means it's none. I even said we were going to find a slant, didn't I? All right, so how do we find a slant? Well, we know we have a slant because the degree is only greater by 1. So if that was an x cubed over x, we wouldn't have one. But because it's just bigger by 1, we could have a slant asymptote, and we find that by long division. So I'm going to go ahead and do x squared minus 4 divided by x plus 3. It'll be an x squared, x times be 3x, and then nothing, and I would subtract, and I would subtract. So I get negative 3x minus 4. And now x goes in there negative 3 times, and I don't even need to finish. Right here is going to be my slant asymptote. So my slant is at x minus 5. X minus 5. So I would be at, this is 3, so x minus 5. My y-intercept would be down here at negative 5 with a slope of, sorry about that, with a slope of 1, and it would be something like that. So now we have this cross place, and this is where our graph would occur. So we need to find our zeros. Our zeros would be at negative 2 and positive 2. So at negative 2 and at positive 2 would be our zeros. And then our y-intercept we already have at negative 3. And so our vertical asymptote, is at that -3 would be our y-intercept would be when x is 0. So if I make x 0 here, I would get a -4/3, so -4/3. My y-intercept is -4/3, so let's just say it's about right there. So it looks like to me that our graph is going to come in and do something like this, and then it'll probably be in this, probably somewhere in this little part right down here. All right, so now we figured out our slant and a hole, and I hope that gets you well on your way to graphing. Get ready for your warm-up tomorrow. Go Bearcats! Okay, now we're going to review the rules for horizontal asymptotes. We are going to compare and analyze the degree of the numerator, the highest degree of our numerator, compared to the highest degree of the denominator. There are 3 examples. Look at the numerator. We're going to focus on the numerator. The numerator here, the degree is higher in the numerator. So this is higher in the numerator. In the second one, it is lower in the numerator. And in the third one, it is the same. So, if we are higher in the numerator, if the degree in the numerator is higher or larger than the degree in the denominator, we have no horizontal asymptotes. We may have slant asymptote if the numerator degree is greater by 1. So Bearcats. All right, let's take a look at the second example. The degree is lower in the numerator. If it's lower in the numerator, then our horizontal asymptote will be y equals 0. So if it's smaller at the top, you get y equals 0. Larger at the top, you have no horizontal, but you could have a slant. And finally, when they are the same, our horizontal asymptote will be comparing, since we can't make that comparison, they're equal, we'll go and look at the leading coefficient divided by the leading coefficient. So in this case, that would be y equals 2/3. And that's how we find our horizontal asymptotes. Go Bearcats!